Every AI model you use was trained the exact same way. It read 15 trillion words before it answered a single person. That's most of the public internet, a library of books, and a mountain of code, and today is the story of how all of it gets in. And here's the part almost nobody warns you about. Once that reading of 15 trillion words is done, there's one thing this machine can never do again, no matter how badly you might want it to, and it's the reason the stuff you type into a chatbot is nearly impossible to pull back out.
Hey everyone, Erica here. And Nova, that number is doing something to my brain, 15 trillion. Because the honest headline for how AI models are trained is really just that, they read almost everything humans wrote down.
This is Lewis. Nobody sat in a room writing the answers by hand. That's the misconception I want to retire in the first minute. The knowledge isn't typed in, it's pressed in by reading.
Okay, hi, I'm Kim, and I have 3 follow-up questions already, which is my normal state. But the one that stops me is Nova's line. It reads everything, and then it can't forget. Both halves of that sound impossible.
Both halves are true, and we'll earn both. Last episode, we promised we'd open the file. Before you read what's in it, you watch how it got filled, and it gets filled like this. Every post, every book, and every line of code. All of it pouring toward one machine at once. 15 trillion words isn't a number you can feel. So hold that picture, because it tees up the question we get more than any other one.
And here's that question, Nova, because it's the assumption sitting under all of this. Most people picture it exactly like this. Quote, so it just copied the entire internet into a giant file. And that's wrong in a specific, important way.
It didn't copy it. It read it and threw almost all of it away and kept only the patterns. That difference is the whole video. So let's walk into the factory and start where the machine starts, which is a mountain of text that has to come from somewhere. So where does a mountain of 15 trillion words even come from? Because that's the first phase, and it has a name, pre-training. And this whole episode lives on layer 4 of the AI stack, the training run, the months-long factory that turns a blank machine into an assistant.
And pre-training is almost boring when you say it plainly. You show the machine a piece of text with the last word hidden, and you ask it to guess that word. Then you do that a few trillion times. That's it. That's the engine.
Predict the next word, over and over, on everything. And I want to name where everything comes from, because people picture a tidy database and it's nothing like that.
The biggest slice is the open web. There's a free public archive called Common Crawl that has been scraping the internet since 2007, petabytes of it. Over 300 billion web pages plus all the code people wrote in the open, with billions more added every single month.
Then you add the cleaner stuff. Books, code repositories, so it learns to program. Wikipedia, weighted heavily because it's dense and mostly right. When they built GPT-3, filtered web was about 60% of the mix. The rest was books, Wikipedia, and curated text.
Look at what the web slice really is, though. It's us. It's a decade of people typing into the void.
Here's how real that gets. Picture a night shift nurse who answered a stranger's medical question on a forum back in 2017. 3 sentences, then she closed the tab and forgot it. Those 3 sentences are almost certainly in the pile now.
She never signed anything. That's the uncomfortable part, and we're going to leave it uncomfortable for now, because the whole fight over it's its own episode. Today we just follow the text into...
Wait, hold on. So it just memorizes all of that word for word?
No, and that's the single most important correction in the episode. It's not a filing cabinet. It reads a sentence, nudges its internal dials a hair, and throws the sentence away. What survives is a statistical residue, not the text.
Let me put a plain words name on this first phase so it sticks. I'm going to call it the big read. Months of the machine reading everything and keeping only the pattern underneath. The big read is phase 1, and it's by far the biggest.
And it's not raw scraping, which is the last myth to bust. Here's the obvious worry, and it's a fair one. If it just grabs the whole internet, isn't half of it garbage?
Yes, and it'd be if they used it raw, so they don't. Teams spend enormous effort deduplicating, filtering out spam and junk, and weighting good sources higher. The quality of that filtering matters as much as the size of the pile. Which is exactly why the next phase needs a building full of chips.
Let me actually show you what 15 trillion words means before we spend a single second on hardware. Because the scale is the thing people can't feel. You, reading nonstop. No sleep, no breaks, one word after another. A token is about 3/4 of a word, so 15 trillion tokens is north of 11 trillion words, and the math on reading them all comes out past 100,000 years. One model reads the same pile once in a matter of weeks. That's the gap. One thing before the next part, and then we move right on. If any of this is clicking, tap that like, hit subscribe, and ring the bell for the next one. It takes a second, it costs nothing, and it helps more than you would think.
Okay, I have to say it. When I first learned this, I pictured one big smart computer doing the reading. It's not one computer, not even close.
It's a warehouse, rows and rows of specialized chips, all wired together, all grinding on the same problem at once. This is the physical machine behind the phrase trained on the internet.
And it's the same downhill nudge from last episode. We already ran this experiment, just with one tiny network. Guess, measure the error, adjust the dials a hair, now run it 15 trillion times, across thousands of chips talking to each other.
Before I show you the number, picture the warehouse. One of the biggest recent models, one training run. How many of these chips do you think it takes? Kim, you first.
1,000 feels high already. I'll say a few hundred, and I'm nervous about.
No, 16,000.
16,000, wildly off. Okay, I concede.
And it's worse, in a fun way. Let me tell you what one real run looked like. Meta trained their big model on 16,384 of these GPU chips, running flat out.
For how long?
54 days, one stretch. And here's the detail I can't get over. Across that run, a chip failed on average about every 3 hours. 419 failures. And the run just kept going around them.
A chip dying every 3 hours for 2 months straight, and it still finishes. That's a factory, not a laptop.
Each of those chips is billions of tiny switches doing the same simple multiplication over and over. That's all training is, at the metal. And I want to hold one number back for a minute because it flips everything you'd expect. Here's the loop I want you to hold. After all of that, all 15 trillion words, 54 days, a warehouse of chips. The machine you get isn't yet the helpful assistant you talk to. Not even a little. Hold that number and that gap. Before this section ends, the next phase explains why.
Right. Because everything so far just built a very expensive autocomplete. The next few minutes are where it actually becomes something you'd want to talk to.
Remember the number I held back, the personality gap. Here it is. After the big read, the raw model is a genius autocomplete with no manners. You type a question and instead of answering, it might just write 10 more questions because that's what the internet does. Fine-tuning fixes that.
It's the difference between a machine that knows everything and a machine that will actually help you. Those aren't the same machine yet. Phase 2 fixes that, and it has a name. Fine-tuning.
And the mechanism is almost sweet. It's my allotment, honestly. The wild field grows everything, but the flavor comes from the small patch you actually tend. You show it examples, a question, then a good answer written by a person, then another, then thousands.
If you keep one line from this whole part, keep this. Pre-training teaches it the world. Fine-tuning teaches it the job. And I'm leaning in for the next bit because the scale flips completely.
Wait, this is the part that shocked me. Pre-training was 15 trillion words. Fine-tuning is what? Millions?
Tens of thousands of examples, sometimes fewer.
That's nothing. That's a rounding error next to 15 trillion. And that tiny dataset is what gives it a personality.
Let me put the whole assembly line on the board because we're 2/3 through it. Pre-training, the big read, the mountain of text. Then fine-tuning, the small set of good answers we just covered. Then human feedback, still coming, where people weigh in. 3 steps, and that's the entire factory.
Which means the personality is trained, not born. There's no little helpful spirit in there. Somebody showed it what helpful looks like, and
It's a walking encyclopedia that just got 1 week of table manners.
1 week of onboarding after 100,000 years of reading. I'm keeping that. And it's the honest version, actually. The helpfulness is a thin, deliberate layer on top of a giant, indifferent one.
But fine-tuning alone still isn't enough, and that's the real cliff. Show it good answers and it gets better, sure. It still has no idea which of 2 decent answers people actually prefer. One question decides the whole feel of a chatbot. Who taught it taste?
Who taught it taste? People did. They rank its answers directly. This is phase 3, and it's the part most viewers have never heard named. It's called RLHF, Reinforcement Learning from Human Feedback.
And it's refreshingly low-tech at the human end. The model writes 2 answers to the same question. A person looks at both and clicks the better one. That's it. That's it, over and over. Do that hundreds of thousands of times.
Those clicks train a second little model, a reward model, whose only job is to predict which answer a human would like more. Then the big model gets tuned to chase that reward. Human taste turned into a score, baked back into the machine.
And this pays off the big read. The raw model kept whatever patterns helped it predict text, remember, with no sense of good or bad. This is the first moment a person tells it which answer we actually prefer. The ranking is why chatbots feel the way they feel. Polite, careful, a little.
Wait, say that back. The whole tone is a vote?
A vote, basically. The politeness isn't a soul. It's the average of what thousands of human raters clicked approve on. If the raters reward caution, you get a cautious, hedgy machine. The tone is trained, same as everything else.
Which is a big claim, and it deserves the honest version. Its manners carry whatever the raters happen to prefer, biases and…
Stop. Read me the actual line then. I want that receipt.
Fair. Lewis, you pulled the paper. Give her the receipt.
The 2022 InstructGPT work, their own finding. A small model tuned with human feedback was preferred by people over the original model that was 100 times bigger. Taste beat size. It's right there in the abstract.
Receipt accepted. So the thing that makes a chatbot feel smart to us is partly that it learned to sound the way we reward it to.
That's the honest version. The big read gave it knowledge. Fine-tuning gave it the job. Human feedback gave it the manners, which means its manners carry whatever biases the raters had. Worth knowing before you trust the tone.
So 3 phases, and now the machine talks. But there's a catch buried in how it was built, and it's the one that follows you home. Everything so far was about getting data in. The next part is about the fact that it can never come back out.
Everything so far keeps a model useful. This next part is where it gets strange, and it pays off the very first thing I told you. Remember from last episode, training doesn't save your sentence anywhere. Reading it just spread a faint dent across billions of dials, mixed in with everyone else's dent. That's what people mean when they say the knowledge is smeared across the weights, and it has one wild consequence nobody expects.
It means you can't cleanly delete one fact. There's no row to find and erase. The fact you want gone is tangled into millions of connections that also hold 1,000 other things.
And researchers actually tested this. They tried to make a model unlearn something. It looked erased. Then they did a little fine-tuning and recovered most of it, about
how much came back?
roughly 40%, I want to say. No, let me be exact. In one study, fine-tuning recovered about 88% of the accuracy the unlearning had appeared to remove. It was hidden, not erased.
So the nurse from earlier, with her 3 sentences from 2017. This is the loop I opened the whole video with. There's no undo button for her. Not because anyone is cruel about it, but because there's nothing single to point at and remove.
Which is genuinely my one over-researched, underwatered houseplant of a worry in all of this. I keep circling it. But the real answer for you is smaller and more useful. If you wouldn't put it on a postcard, be careful typing it into a chatbot that trains on your chats.
There's a second data problem worth naming though, and anyone can check this one. It's the opposite. Not too much of our data, not enough.
This is the running out problem. Teams already deduplicate and filter hard because raw web text is full of junk and repeats. But researchers at Epoch AI estimate the stock of good public text is around 300 trillion tokens, and that models could use it all up somewhere around 2028.
Which is why, to borrow Nova's word, the big read might not always have enough to read. So the industry is reaching for synthetic data, a model generating text to train the next model.
And here I want to be honest both ways because this one's a real fork. It genuinely cuts both ways. Synthetic data is genuinely useful. You can fill gaps, cover rare cases, and dodge some privacy problems. That's the real upside.
And the real downside is a model teaching a model can drift away from reality quietly and reinforce its own mistakes. It's a genuine tool and a genuine risk, not free lunch. The fix is boring and correct. Keep checking it against real human-sourced data.
So that's the loop I promised, paid in full. Your data goes in and it doesn't come back out. And that's the small version. Stack the copyright fight on top. Every book and song and artist's work in that same pile, and the number of people who care gets much, much bigger. Hold on, because that's its own whole episode.
So let's stand back and say what we actually just watched. It's prediction, at a scale nobody can really picture, and the honest frame matters more than any single number.
Here's the whole factory, top to bottom. You gather a mountain of human text and filter it hard. You point a warehouse of chips at it and have the machine predict the next word, trillions of times, until patterns press into billions of dials. Then you fine-tune it on a small set of good answers so it stops rambling and starts helping. Then people rank its replies until its taste matches ours. 3 phases. Months of compute. And out the other end comes something that can write, explain, and answer with no one having written a single rule. That's how AI models are trained.
And it's prediction at scale. That's the whole factory, end to end. A mountain of text, a warehouse of chips, 3 rounds of shaping, and out the far door comes a system that got very, very good at guessing what comes next.
But it was trained on us, so it reflects us, our knowledge and also our blind spots and our nonsense. That feels like the part people skip.
It's the part people skip. And it's exactly why I want to bring in someone who knows these training pipelines from the inside out. Priya Lindquist knows how these models get trained, from the data up. Priya, you on the line.
I'm on. And let me flip one thing around first because people get it backwards. The interesting question isn't whether the model remembers your data, it's that removing it means retraining, and nobody retrains a giant model to pull out one sentence. 2 very different problems, and people argue about the wrong one.
So when someone asks, can you just make it forget me? The honest answer is what?
The honest answer is not cleanly and not cheaply. 9 times out of 10, what actually happens is they filter you out of the next training run, not scrub you from.
So removing anyone is just flat out impossible, basically.
Not impossible, just not on demand, and not from a model that's already trained. Leave you out of the next run, and over time you fade from the line. That's the real mechanism, and it's the one to hold.
Okay, but the training data is basically the whole show, right? The architecture barely matters next to it?
Depends what you mean by matters. Same data and a better recipe, you get a sharper model. So no, the design isn't nothing. But if I had to bet where quality comes from, it's the data, cleaned well, every time. That part I know cold. Where I would stop is the law. Whether all that scraping was allowed is a courtroom question, and I would want a lawyer for it, not me. But you two see how people actually use these tools more than I do. What's the one thing you'd tell them?
Here's the ruling, and it's the whole series in one sentence. Prediction at this scale is genuinely powerful and genuinely limited at the very same time. So verify what it tells you, the same way you'd a confident stranger. Thanks for calling in, Priya.
Anytime. Just remember, it's a mirror we trained, not an oracle we built. Talk soon.
A mirror, not an oracle. Yeah, that's the one I'm walking out with.
So here's the whole thing in one picture. We don't write the answers into an AI. We run a factory, read the internet through it for months, and let the answers come off the line.
Off the line, not out of thin air. And the payoff for you is real. The next time a headline says an AI magically learned something, you'll know there was no magic. There was a mountain of text, a warehouse of chips, and a lot of people clicking which answer was better. You could walk a friend through that over coffee now.
Coming up, we rewind to one research paper from 2017, the single idea that made all of this possible, the transformer. A handful of researchers, a strange title, and an architecture that swallowed the entire field.
If this is the first time training ever actually made sense, hit subscribe. We're taking this whole machine apart, one piece per episode, and I want you here for the rest of it. And here's the fight we couldn't put to bed today, so it's yours. If a model is trained on all of us, and it can't forget any of us, who gets to decide what goes into it in the first place?
If one section applies to you, that section is the homework.
That's the one worth arguing about. For Erica, Lewis, and Kim, I'm Nova. Thanks for touring the factory with me, and I'll catch you at the next layer down. The second dataset clarifies the first. Always check the second one.
Great job, Nova. I would say 8.5. Room for improvement keeps you hungry. This is Professor Erica. Thanks for watching and signing off.